Alright, welcome to 6.5 mutually exclusive events. So, this will be the last lesson for chapter 6. So, recall that an event is something that we're looking for in an experiment or observation. So, event A is rolling a 3, event B is rolling a 5. So, A union B is rolling a 3 or a 5. So, union is reflected on the OR. Okay. So, mutually exclusive. So mutually exclusive means that there's no objects in common. They are totally separate. A does not infringe on B. If that is the case, the probability of A union B, or A or B, is the probability of A plus the probability of B. If you want to see the proof, come see me tomorrow and we'll discuss the proof. Okay. So example. So a committee of 5 is to be chosen randomly from 6 teachers or 8 students. What is the probability that the committee is all teachers or all students? Obviously, since we're looking at all teachers or all students, this is mutually exclusive because a teacher and a student are not the same in the same context. Not to say that a teacher can't be a student or a student can't be a teacher, but in this context, they're separate. That was the solution. Okay, so we can either do it in 2 cases, which is essentially the same thing. So all teachers, so there's 6 teachers, we choose 5. 8 students, we choose 0. Over 14 altogether, choose 5. So we get 6 times 0 over 2002. The 6 over 2002, which can be reduced to 3 over 1001. Case 2, all students. Again, 6 choose 0, 8 choose 5, over 14 choose 5. It's 56 56 over 2002, which is 28 over 1001. And since they're mutually exclusive, we add the 2, so we get 3 over 101 plus 28 over 101 is 31 over 1001. Therefore, the probability of the committee, all teachers or all students, is 3%. Okay. Mutually non-exclusive. It means 2 events are not mutually exclusive, so therefore they should have some shared common outcomes. So remember from chapter 5, we said that the property of inclusion and exclusion says that the number of elements A or B is equal to the number of elements in A plus the number of elements in B minus the number of elements in the intersection. Similarly, we can use probability, just replace number with probability, and we get the same essential formula. So, an example. So, a card is randomly selected from a deck of standard deck of cards. What is the probability that it is either a spade or a non-face card selected? So, obviously, these are non-mutually exclusive events since there are cards that are both spades and non-face cards. So, the probability of spade or a non-face card is the probability of a spade plus the probability of a non-face card minus the probability of a spade that is a face card, non-face card. So that's 13 over 52, 40 over 52, and 10 over 52, which is equal to 43 over 52, which is equal to 0.8269, or 82.7%. Therefore, the probability of selecting a spade or a non-face card is 82.7%. And that is all our questions for today. So here are some questions, try those, and then we'll discuss more.